Hello and welcome to the session. My name is Akshay Kumar. I'm an associate professor in the School of Computer and Information Sciences, IGNOU. And today I'll be discussing with you about the topic total project time and critical path in the context of project management. Well, in the last session, we have discussed about the techniques of network analysis, and which were basically PERT and CPM. And in this particular session, we will be developing more on them. We'll be discussing more about these two techniques. The very first point in this context I would like to state is about the total project time. Now, each activity in a network analysis diagram has a successor event as well as a predecessor event. So an activity which we shown as the start, the tail event and the head event also, right? Okay. The time during which an event can be completed is the maximum time of the various paths flowing into that event. So this is something which we will be dealing with, that is time during which an event has been completed is the maximum time of the various paths flowing into that event. So this we would like to demonstrate to you. So suppose an event is completed by 4 different paths. There are right. So if it can be completed by 4 different paths, then all those 4 different paths, if they are to be performed in parallel, must be completed. When all those 4 paths is completed, the maximum of those paths, whatever time, whichever the path which takes the maximum time, is the time of completion of the entire event. So this is something which you really need to understand in this particular context. Then the total project time is the maximum of the elapsed time among all the paths in between the starting and ending event of those project network. So this is something which you need to see as we are going to discuss about the starting and ending event of a particular project. Then to calculate project time, if you want to calculate the project time, then we have certain terms which we use, or some words which are going to be here. The first one is calculating project time is with EI, basically, which is earliest occurrence time of an event. So earliest occurrence of a particular event or earliest completion of a particular event is not there. Then EJ basically is earliest occurrence time of, this is another event which is there in that particular sense. So I and J. And the latest occurrence time of a predecessor event is called Li, and latest occurrence time of the successor event is the Lj, we can say. And Tij is the time of a particular activity from event I to event J. So these are some of the basic terms which are used for computing the time. However, we won't be, these are given in your block. We will be very specific. You don't need to remember these definitions or this is what it is. It is very obvious, and you can make out the whole diagram, or the whole diagram is very obvious, and you will if you be with me and compute with me, and you will really enjoy this particular computation for various that is computation of project time. Well, what we have already stated is that when we are computing the project time, we have the ith node as well as jth node. So ith node is ith event, jth node is the jth event, and Tij is the time taken in the activity where the predecessor node is I and the successor node is J, which is where the you can say the tail node is I and the completion node is J. And EI is the earliest occurrence of time for this particular event, and Li is the latest occurrence time for this particular event, and EJ accordingly for the other one. So from EI, using EI and TI, we are going to compute the EJ and LJ. Okay, and using LJ, we'll be using computing Li. So this is something very interesting, right? Now we begin with the starting event, calling it 0 time. And that means E1 happens to be 0 for the starting event, right? And we proceed to each event in sequence and compute the earliest start time EJ for all other events. And it is basically, the formula for computation is EJ equals to maximum of EI plus TIJ. So now this is going to be from EI, like what we said, from the ith to jth node, right? So we will be using EI, adding TIJ in it, and we will be getting the EJ part of it. Okay, the earliest time of completion of the next event, or the event which has been which will be completed after that time. Now, a very interesting point which you have to understand, the word max is here. So all the paths, we are going to take the maximum of all the paths, and that is what is being indicated over here. After reaching at the last event, we will make the EJ of that particular event as LJ of that particular, or the latest completion time of that particular event, and start computation in the backward direction with the help of a different equation which we will be using in this particular case, and that equation is going to be Li, that is the completion time of the previous event is going to be minimum of Lj minus Tij. Now this is another interesting, so I mean these terminologies are fine, but then unless we do an example, you won't be able to appreciate what exactly is going on, and you have to be very particular about this particular equations, because they look very difficult, but logically they are very simple. Okay, and that's what we want to see. So this process of computation of Li value for each event will continue till the starting event of Li equals to 0 and Ei equals to Li equals to 0 is obtained. So this is how we are going to compute the project time. Let me explain this concept of project time with the help of an example. Now let us assume there are events 1 to 2 which takes time of unit 4, 2 to 3 takes 5, 2 to 4 takes time 6, so 2 to 5 takes 7, 3 to 6 take 10, 4 to 6 take 9, 5 to 4 takes 0, so this is a dummy event, okay, dummy activity. Then 5 to 7 takes 8 units and 6 to 7 takes 3 units. So this is the kind of data which will be available. You have 7 events, and among these 7 events there are several activities which are taking place, and you got to produce the network diagram for it. Now how the network diagram for this will look like? Well, you can directly see over here the circles are showing the events. So you can see that there are 7 circles, and these 7 circles are named 1 to 7, 1 2 3 4 like that, 7. Okay, so these are the 7 events, and the event the activity 1 to 2, right? There is an activity from 1 to 2 which is taking place. Okay, so this activity is shown. You can see this particular activity took the time 4, right? Duration for this activity was 4, and that is exactly what being shown. From event 2 to event 3, the activity takes the time 5, and that is precisely which is being shown. 2 to 4, the time is 6, and that is what you can see is being shown, right? So like that, the timing of various activities has been mapped onto this particular diagram. So now this diagram is ready for some kind of network analysis. So first analysis which we are going to start here is, we are going to start with the event node 1, and what you can see at event node 1, the value is at that particular event node E equals to 0. Okay, so that E equals to 0 is there. And what you can see that once you move from this particular event, the only possible event which is going to be possible is event 2. So you will be only able to, with your activities, the 1 is going to lead you to event 2, and the time is going to be taken is going to be 4 units, and that's what you see. The E of event 2 happens to be 4, right? Because E of unit 1 or event 1 was 0, so 0 plus 4, which is the activity time, takes us to earliest occurrence time of event 2, which is going to happen, this particular event is going to start at, this event will occur. Events does occur, they don't start, right? So this event is occur at event time equals to earliest time is unit 4. Now from 2, what we see, there are 3 possible events which will get fired, event 3, 4 and 5. So now what we see, like first 2 to 3. So event, if you see 2 to 3, what you see, E equals to 9. How that E equals to 9 is going to come? So our earlier occurrence time is 4. So 4 plus activity time of 5. So at what you see at 3, earliest occurrence time of event 3 happens to be 9, because 4 plus 5, E. So we are just dealing with E, we are not dealing with L right now, right? So that's how you get 9. What about from 2 to 4? So if I see 2 to 4, what was the earliest occurrence time of unit 2, event 2? 4. So plus 6 more unit. So for event 4, what we we have one time earliest occurrence time is 10. However, what we see in event 4, there are 2 paths, right? And the second path is coming from 5 to 4, and the length of that particular path we do not know, right? So so that is why it is not yet determined. We cannot determine E for event 4 for the timing, but from event 2 to event 5, what you see, okay, so 4 plus 7, so 11. That is the earliest earliest occurrence time of event 5, which happens to be 11. And because of event 5, event 4, the activity time is 0. So event 4 also is going to be occurring, the earliest occurring time of event 4 is also 11 if I am using the path 2, 5, 4 instead of 2, 4 directly. Okay, so now what you see, when we were moving from, when the events were happening from event 2 to event 4 directly, then the earliest occurrence time was 10. But event has not yet occurred, because we are going to consider the maximum time in this particular case, which is happening when event 2 is occurring, followed by event 5, and then followed by event 4, occurrence of event 4. So this particular path, through this particular path, the event is going to occur at the earliest occurrence time of event 4 happens to be 11. Okay, 10 and 11. Okay, and then moving on with this. So suppose from 3 to 6, what is the earliest occurrence time? E was 9. So 9 plus 10, 19. Okay, whereas from 4 to 6, if we are moving to, from event, the other path. So first path was 3 to 6. Okay, the total computation over there is 19. From 4 to 6, the computation time is E of 4 is 11 plus 9, so it is going to be 20. So maximum of these two, 20 is taken. So earliest occurrence time of event 6 happens to be 20. Alright, and then once again 7 also faced this particular situation. The path, once again, we either go from 6 to 7 with the time 3, so 20 plus 3 becomes 23. On the other hand, that is the earliest occurrence. If we event 6 to 7, the activity 6 to 7 is taken, it's going to be taken up, but it is going to take a time of 23. Whereas from 5 to 7, it is 11 plus 8, just 19. So maximum is taken and we get E equals to 23. All right. So at this point of time, okay, E is complete. So what do? We just go back. Okay. So now let us, before we go to the reverse cycle, that is the latest or the last, latest completion occurrence time. So we go back. Before we do that, let's look into this particular slide. Computation of earliest occurrence time of the event. Earliest occurrence time. So event 1, the activity, there was no activity. Activity time is 0. So the earliest occurrence time of the event 1 happens to be 0. The event at the event 2, the activity event 2 is going to occur when the activity is from 1 to 2, and activity time for this is 4. So earliest occurrence time of this case is 4. Okay. Now from moving from 2 to 3, 4 plus 5 equals to 9. Now 2 to 4, there are two paths, right? There is one path from 2 to 4, 2 to 5 and 5 to 4, right? So look into 2 to 4, 6 plus 4, so we get 10, okay, and you can see the 10 has been striked off. All right, so why it has been striked off? Because it is less than the other path, which is from 2 to 5. So we get, it should be 4 plus 7 equals to 11. All right, because the earliest time for that is earliest time of event 2 is 4, right? So 4 plus 7 happens to be 11, and 5 to 4 happens to be 0. So 11 plus 0 is 11. So 11 and 10. 11 is greater than 10. So earliest occurrence time of event 4 happens to be 11. Okay, 5 is already there. The earliest occurrence time of event 5 is 11. Okay, event 6, now you can see once again there are two paths and maximum of the two is selected. 9 plus 10 equals to 19 and 9 plus 11 equals to 20. This is what I explained in the diagram, and this is now the table also shows the same thing. So you can refer to the table as well as the diagram in a cyclic way. All right, and similar thing happens in the 7. Remember this particular PERT diagram is this particular diagram is already there. This network diagram is already in your block, so you can refer to your block also if you want to refer to the diagram, network network diagram. All right, so similarly you can see the whole thing has been computed. Okay, and this is for activity 6. There were a maximum of 9 plus 10 or 9 plus 11 is selected, which happens to be 20. Similarly for activity 7, right, maximum of 20 and 20, so you get this particular information. For activity 4, 11 plus 0 or 10, so 11 is going to be selected, and that's precisely what has been done in this particular case, and this is reflected in the diagram as well. Now we have to do the other extreme, and that is computation of latest occurrence time of the event. Latest, like this earliest this event is going to occur at this time, but what is the latest time at that point of time this event is going to occur? To compute it, we start from the last event or the destination event we start, and the latest, the time remains the fixed time, right? So the latest time of occurrence of the event 7 is going to be same as the earliest completion or occurrence time of the event 23, because project is to be completed in this particular duration, right? So from 23 we start. Now from 7, if we go back to 6, right? So that is 23 minus 3. So the latest occurrence time of event 6 happens to be 20, that is 23 minus 3, whereas the latest occurrence time based on paths 5 to 7 of event 5 is going to be 23 minus 8, 15, right? But you can't see 15 in L of the node 5, because in this particular case we will be selecting the minimum. Okay, but the minimum has not yet arrived, so that is how we will continue. From 6, there are once again 2 paths. So if we go back to that is the the latest time of completion of 4, it is going to be 20 minus 9, which is going to be 11. So you can see L at 4 is 11. Similarly, the latest completion time of node 6 was 20. So the latest completion time of node 3 is 20 minus 10, which happens to be 10. So that is what you can see. Now you can see there is a difference in node 3, where earliest occurrence time is 9, whereas the latest occurrence time is 10. So the latest, like that means you can delay that particular event by 1 unit if there is a need so be. And that is a very important resource allocation information for us. Okay, moving back from 4 to 5, right? So as we have arrow from 5 to 4, or the activity from 5 to 4, which is the dummy activity, even then, so latest occurrence time for 4 was 11, so is going to be the latest occurrence time of 5 to be 11. So what you can see, 11 and 15, you got to take the minimum of it, and you get 11 as the latest occurrence time of event 5. From 5 to 2, it is simply 11 minus 7, so it becomes 4, right? From 4 to 2, the 11 minus 6, it is 5. From 3 to 2, it is 10 minus 5, it is 5. So we take the least, which happens to be the 4. Okay, so the least happens to be 4. So the latest occurrence time for unit for event 2 happens to be 4. And once again, when we go back to the latest occurrence time of 1, it happens to be 4 minus 4, which is going to be 0. So once again, let us recapitulate what we have done. Let us recapitulate this with the help of a diagram where computation of latest occurrence time of the events are being computed. Now we will start from the bottom in this particular case. So first is that we start that the event 7, the latest occurrence time happens to be 23. Now because of path 6 to 7, the event 6, the latest occurrence time is going to be 23 minus 3, which is 20. Moving once again from 7 to 5, like from 5 to 7 with path 5, the earliest occurrence, the latest occurrence time is going to be 15 for node 5, but there is another entry for node 5 and which is less than 15. So that is going to be, that has been selected, and that is why it has been striked off. And 4 to 6, whatever, I think the 4 to 6, we have deducted 9, then 10, and from 3 to 6 you see the time 10. Similarly from 5 to 4, because of 5 to 4, the earliest occurrence time of event 5 is, the latest occurrence time of event 5 is going to be 11, like that. Now 2 is a very interesting case, as we were discussing. There are 3 possible paths for from event 2. So 2 to 3, 2 to 4 and 2 to 5. So the 5 is the latest occurrence time for node 5 is 11. So 11 minus 7 happens to be 4. Similarly, the latest occurrence time for 4 is also 11. So 11 minus 6, which was the path, the time taken during the path is 5. And similarly, for 2 to 3, 10 minus 5, you will get this particular 5. So both the 5s are more than 4. So we take the latest occurrence time as 4. And finally, for event 1, it's going to be 0. So this computation for activity 2, you can see minimum of 5, that is 10 minus 5, or 5, 11 minus 6, or 4, 11 minus 7. So 4 is being selected. Similarly, for activity 5, minimum of 15, 23 minus 8, or 11, 11 minus 0. So 11 is selected, and they become the occurrence time which has been recorded in the diagram duly. So you can see all those times which has been computed now has been recorded in the diagram. So what do? We have created this earliest occurrence time, right, and the latest occurrence of a particular event. What do we do with these times, right, with these timings or something? There has to be something related to this particular thing, and that is what we call it critical path. We need to find the critical path using this particular diagram, which includes latest as well as earliest occurrence time of the events and activity time. Okay, so critical path is the path of longest duration chain amongst the all possible paths. Longest path we are looking forward. So in the given example, how do we find this particular critical path? Okay, we find critical path by finding critical activities, and the events on that path is called critical event. So what we got to do? Critical activities we have to identify, and all the events on that path is critical events. And the critical activities in the diagram which we have constructed happens to be 1 to 2, 2 to 5, 5 to 4, 4 to 6, and 6 to 7. Now how do we determine that? Let's go to the diagram. Okay, now what we see in this particular diagram, when we start, now one of the major recognition point of a critical event is that for critical event, the earliest occurrence, okay, the earliest occurrence time, okay, the earliest occurrence time and latest occurrence time are the same. Now that's a critical event. So what we see, 1 is a critical event because E equals to 0, L equals to 0 for this. 2 is also a critical event because E equals to 4, L equals to 4. But 3 is not, because E equals to 9 and L equals to 10. Remember this, L has to be greater than E. Okay, L either will be equals to E or greater than E for this kind of analysis, the critical path or method. This has to be there. Okay, so if you are getting L less than E, there is some error in your computation. Okay, so what we see once again, so 3 is not a critical event. Okay, what about 6? 6 is a critical event. Okay, and 7 is also a critical event. 5 is also a critical event. Okay, 4 is also a critical event. Now that means our path is going to be 1 to 2 is assured, but 2 to 4, as you remember, 2 to 4 we have got 10, right? Whereas 2 to 5 and back to 4 we have got 11. So our critical path is going to be 2 to 5 because 5 is also a critical event. Okay, so 1 to 2, 2 to 5, 5 to 4, because you remember 5 to, if we say 5 to 7, it is not a critical activity, right? It is not a critical activity. Why it is not a critical activity? It was leading to L less than 23 if we move directly from 5 to 7, because 11 plus 8 was 19. So what we have is 1 to 2 is a critical activity, 2 to 5 is a critical activity, 5 to 4, yes, 4 to 6 critical activity, and 6 to 7. So that makes our path, right? So that makes our critical path. Remember, it's very, very important that you select the correct path, right? And the correct path is 1 to 2, and 2 to 5, 5 to 4, 4 to 6, 6 to 7. 3 in any way is not part of it, right? So from 1 to 2, when you have moved, there was possibility of 2 to 4 or 2 to 5. So which activity is critical? 2 to 5, because that led to E equals to 11 for 4. Alright, so therefore 2 to 5 has been selected, okay, and then 5 to 4, and not 5 to 7. Why? Because at 7, L equals to 23 and E equals to 23, and over here if we say E equals to 11 plus 8, it becomes 19, less than that, right? It's not possible, right? So we go from 5 to 4, 4 to 6, and 6 to 7. So that selection is the most important selection when we are dealing with critical path. So what is our critical path? 1 to 2, 2 to 5, 5 to 4, 4 to 6, and finally 6 to 7. Now what does this critical path, so this is what critical events are, 1, 2, 4, 5, 6, 7. I would have, you could have written it in a better way by writing 1, 2, 5, 4, 6 and 7, so that the paths are very clear. Okay, so critical activities are 1 to 2, 2 to 5, 5 to 4, 4 to 6, 6 to 7. So that is how the critical event should have been numbered also. Okay, then total project time 23. So we are assuming the units to be weeks. So that is what the 23 weeks are. Now an interesting concept which is coming over here is called the float. Now float is the extra time available with any activity. Extra time can be utilized for scheduling and resource reallocation. So the total float can be computed with the equation total float equals to the latest completion time, okay, latest occurrence time minus earliest occurrence time, right, minus the Ti to j. Okay, so this is the way it is computed. There is no float for critical activities, whereas float exists for non-critical activities only. And the computation, that is the critical activity, if we see, if I say critical activity 2 to 5, the float is going to be computed, that 5 the what is the that is the event time, latest event time is 11, and the earliest event time for 2 is 4, and we subtract 2 to 5, the path length is 7, so it comes out to be 0. For any critical activity there is no float, because those are the activities which are to be completed in time in order to complete the project in time. Otherwise project will never get completed in time. The float is for non-critical activity also, is only, okay, non-critical activities. For example, 3 to 6, right? Now 3 to 6, if we see, okay, the float is computed as the earliest, the completion time, okay, the completion time was 20, right, latest completion time was 20, right, minus the earliest completion is 9, okay, minus 10, right. So this is how you will get this particular information, 20 minus 9 minus 10, so you get 1. Similarly, from 5 to 7, okay, you will get a float of 4. So this particular activity, 5 to 7 activity, it is to be completed, okay? In order to complete the event 7, 5 to 7 is to be completed, as well as 5 to 4, then 4 to 6 and 6 to 7 is to be completed too. But the float available for 5 to 7 is the 23 is the latest completion time of event 7 minus the earliest completion time of the event 5 is 11 minus the length of the path, which happens to be 8. So you get a float of 4 on path 5 to 7. So if some activity, the activity of path 5 to 7, it can be delayed by 4 weeks. The activity from path 3 to 6 can be delayed by 1 week. In case we are running short of resources, these resources can be utilized for these many weeks onto our critical path activities, right? So those critical path activities once again are 1 to 2, 2 to 5, 5 to 4, 4 to 6, 6 to 7, right? So our target is we complete 1 to 2, then we complete 2 to 5. Okay, we initiate 5 to 7, but then we can delay that 5 to 7 at this point of time. 5 to 4 will be immediately started, 4 to 6 will be immediately started, no delay, 6 to 7. So like that, this is how this is what is the meaning of float is, right? Okay, so what is the significance of critical path finally? No flexibility is available with the planner for changing the schedule of critical activity. You got to do them on time. If you don't do them on time, your project is going to be delayed. Okay, all the critical activities must have to be completed according to the planned schedule. Okay, so otherwise our project is delayed. So this is what is the importance of or the significance of critical path. So what we have covered in this particular session, we started with first finding the completion time or the earliest occurrence time of events and latest occurrence time of the event from the timing from various paths and the activity time of those paths. Once we have found out those earliest occurrence time and the latest completion occurrence time, then on the basis of wherever these two times for a particular event are same, they are the critical events. But then we recognize the critical activities. What are the critical activities through these nodes? Once we recognize the critical activity, that forms our critical path. And we got to make sure that our critical path, we give all the resources, best resources, and then we calculate the float for other paths which are not critical. So if there is a float, we can always reallocate resources so that all our critical activities are completed in time. In turn, we complete our project in time. So with this, I end this particular session. Bye for now.